Hello again, Algebra 2 students. In this lesson, we're going to define and use probability. So as you take a look at the notes that you've got, first question asked is, what is the ultimate poker hand? If you want to know that and the probability of being dealt that poker hand, you'll have to listen in class because we'll talk about it there and not here on the video. Anyways, the theoretical probability of an event. When all outcomes are equally likely, the theoretical probability that an event A will occur is P of A, so the probability of that event occurring, is equal to the number of outcomes in that event divided by the total number of outcomes. So if I have 8 possible outcomes, okay, I'm looking at this Venn diagram over here, and event A is the event that I'm looking for, that's the probability that I'm looking for. Well, there's 3 items in event A compared to there's 8 possible outcomes total. Well, that means the probability of one of these 3 events happening is 3 out of 8, or 3/8. And oftentimes we're going to use fractions as we denote probabilities. Now, you can use this formula over here. Another way that I like to think about it is I like to think about it being success. So as in the number of successes divided by the total. Okay, so success over the total. The success would be, what it is that I'm looking for. I'm trying to flip a head on a coin, or I'm trying to roll a 5 when I roll a die, whatever it is, whatever success is, you take the number of successful options divided by the total number of options that you might have for that particular event. Okay, so a lot of times we deal with probability, we're going to be looking at cards. The first question says here, you pick a card from a standard deck of 52 playing cards. What is the probability of picking an 8? Now, some of you may not be super familiar with cards, so I'm going to take a look at this diagram briefly. So this shows all the cards in a full 52 card deck. So the jokers, those don't matter to us, don't worry about that. Okay, so we're dealing with probability. We've got 52 cards usually. Now, there's 4 suits, there's clubs, and diamonds, and hearts, and spades. Okay, within those 4 suits, 2 of those suits are red, okay, and 2 of those suits are black. Within those suits, you have ace through 10, so like think of it as 1 to 10, and ace is 1. Now, again, games will make that different value, but for us looking at it right now, we've got 1 to 10, and then we've got a jack and a queen and a king. Those are considered the face cards because they got somebody's face on them. So we've got 4 of each kind of card, 4 aces, 4 twos, etc. So as we're looking for a probability here, we were asked to find the probability of picking an 8 out of a standard deck. Well, as I figure out that probability, I think about the number of outcomes in that event, or the number of successes. Well, how many 8s are there in a deck? Well, we figured out that there's 4 8s in a deck because there's an 8 of each suit. So I take 4, my number of successes, divided by the total number of outcomes. If I'm choosing 1 card out of a full deck, that means there's 52 cards available to me. So 4 out of 52, or 4 52nds, that would be my probability. Now, we don't leave a fraction unsimplified, do we? No. So we reduce this to 1/13. So that would be the probability of selecting an 8 if you've got a full deck of cards to choose from. Next, find the probability of picking a red king. Well, going back to our diagram, I notice that there's 4 kings, and of those 4 kings, 2 of them are red. So my successful outcomes here would be 2 out of the full deck, which is 52. So there's 2 red kings out of a deck of 52 cards. That means the probability of getting one of those 2 red kings would be 1 out of 26. So 1 in 26 would be my probability. And that's what I'd have for those first couple of basic probabilities.